Hello people, welcome to another episode of the video series where we learn Kotlin following along Codecademy's Learn Kotlin interactive course. In the last lecture, we went through loops and now in this lecture, we will go through functions. Let's get started. Now that we understand important programming concepts like control flow, collections, and loops, we can learn how to use functions to make our programs more efficient. So, a function is a reusable block of code that we can call throughout our program to complete a certain task. So, a function is a reusable block of code, and we can call functions throughout our program, and each function has a task to complete. Okay, you may recognize the term functions since we've already implemented some in this course. The println function, which we have used to output values, as well as the main function. So functions, as you might remember, has this parentheses when you declare them and when you call them. In this lesson, we will venture outside of the main function and write our own user-designed functions, like this one, campfire. Here, we define a function by putting the keyword fun, and then write a name for our function and a pair of parentheses, and inside this pair of parentheses you write some arguments, or if you don't need any arguments, any parameters, you omit it and you skip, so you don't write anything inside. And in the function body, in between these curly brackets, you write some code, some lines of code. So whenever you call this function, calling means typing in another place of your code, typing the name of your function and putting the pair of parentheses, and if it needs any arguments, this function doesn't, you put some arguments and you call that function. When you call the function, the content inside, the block of code inside, gets executed, so that you can just, with a single line of code, you can execute multiple lines, and you can you can call this function multiple times throughout your program. Cool. Take a look at the image to the right. We already did. After spending a lot of time camping, the task of starting a campfire each night has become cumbersome or tedious, let's say. Usually we extract some tedious operations inside a function. This is called extracting code into a function, and we call this in the rest of our code base, instead of typing everything all the time, the same thing again and again. Luckily, function forest is known to be the habitat of a very smart bird that can remember a set of tasks and repeat them anytime they are called. Code teaches one of these birds all the steps needed to make a campfire: finding rocks to contain the fire, collecting kindling, and starting a flame. Now, whenever Cody wants to start a campfire, they simply call upon the bird. Okay, cool. Let's go to the next exercise. Creating and calling a function. In order to declare a function, we'll need to understand the anatomy of a basic function. A function header contains valuable information about a function, including its name, here, arguments, here, and its return type, here. The fun keyword is used to declare a function. The function name is used to call the function throughout the program. For example, if you want to call this later on, we should write function name and then a pair of parentheses, and then feeding it with some arguments. Okay, like 1, 2, 3. I don't know the type here, so I assumed it's an integer. Cool. So inside the parentheses are arguments, pieces of data fed to the function. The return type declares the type of data the function will return. It is also optional to include. Following the function header is the function's body where the instructions are contained, and that is the function body in between the curly brackets. Cool. We will cover arguments and return types later in this lesson. For now, we will focus our attention on creating a basic function that outputs a value whenever we call it. Let's create a function called greeting that prints hello friend. Cool, this part. A function will only execute when it is called or invoked, while the function greeting will exist outside the main function. We will call greeting within main by writing the function's name followed by parentheses. This is the part you declare your function. It is outside of the main function. You can put it above the main function or below the main function, but outside of main function. And whenever you want to use this, like call this to get its body executed, you just type its name followed by a pair of parentheses inside whichever function you want to use or invoke or call. Anytime we call greeting, hello friend will be outputted to the terminal. Okay, now the instructions. Create a function named s'mores that outputs the following statements using println. Okay, so this is our main function. We until now we have always written our code in between this parentheses, so inside of main function. But now, since we are creating another function, we are going out of this main block, and there's an arrow. You see that you can expand and collapse the body of a function using that. And now we will create a function here. To create it, we start with the fun keyword and then the name of the function, which is s'mores, and then a pair of parentheses and optional arguments inside. And this function won't have any arguments now, so I will skip. And the return type, but return type will also come later, so we also skip it. This is optional as well. And a pair of curly brackets, and in between those, we will write some println statements or functions. We will call println function inside. Roast a marshmallow. Okay, we will print this one. I think we need to 1, 2, 3, 4, 5. We need to call println 5 times and with a different text each time. Okay, place chocolate marshmallow. Put a new graham cracker on chocolate. By the way, a fun fact, I tried to make s'mores. I made s'mores once, but I didn't like it. Maybe the recipe I followed was wrong, but it was too sugary for me. Like the cracker I used was also sugary. The marshmallow was full of sugar, and then the chocolate was full of sugar again. So we couldn't eat more than like a few bites. Afterward, it was too sugary for us. Maybe, I don't know, maybe the recipe was wrong, or maybe I needed to use bitter chocolate, or maybe some salty crackers. And enjoy as the last step. Cool. Let's run this and see if we get a check mark here. Yes, we did. Cool. Now, second part, invoke s'mores function in the main function. S'mores, and then a pair of parentheses, and that's it. You don't write fun, okay? You write fun when you're declaring. But if you're not declaring a function, you just call this function by typing the name and a pair of parentheses, and that's all. And if you have some arguments in between these parentheses, you also need to feed some data inside in place of those arguments. Running this, I think we will get another check mark. And we have an uh, optional exercise here. Call s'mores again. Note how time is saved by calling a function instead of writing the instructions again. Yes, if you want to print this again, we will just type s'mores. And it was like under 2 seconds, we could call this again. But if I wanted to run all of these, I need to write 5 lines of code here more. So this shortens the time, saves the time by cutting out some code. Yep. Now, next exercise. And now we need to learn arguments. Arguments are pieces of data we can feed to our functions in order to produce dynamic results. We can include as many arguments as the function needs. Think of the println function. When we use it, we give it a single argument here, for example, a string value. This value is then passed and outputted to the terminal. To pass arguments into a function, we need to add parameters to our function header. Parameters are the names given to data being passed into a function. For example, we have a function here. The name is calculate function, and it has 2 arguments. The first argument is called mass, and it's an integer, and there is a comma in between these two. And the second argument is called acceleration, and the type here is integer. So when you're writing arguments, you type the argument name and a colon and the type. If you want to add more, you add a comma and another name, another colon, another type. So you can put more, like 2, 3, 4, 5. The syntax allows it. And then you can use these values as variables. So these are variables or values defined, so you can reach them and use them. Okay, so you calculate a force variable multiplying mass with acceleration, and then you can print this in a string template. So this is what calculate force function does. Yes. In the parentheses of the function header, we added 2 parameters, mass and acceleration. We use comma and colons and such. We already talked about these. And now when we are invoking this, like calling this function, then we type the name and a pair of parentheses. But now, since we have some arguments, we need to give those. Here, the first argument is called mass and is an integer. So we need to pass an integer here. And for the second argument, we need to pass another integer, and it is written here. So when calculate force is called, the values 5 and 12 are passed as arguments into the function. The value of the parameter mass will be 5, and the value of acceleration will be 12. So invoking this function will print 60 newtons, because 5 is given into here and 12 is given into here. And if you multiply 5 by 12, you get 60. So 60 is printed. Cool. Let's do an exercise. Create a function called getSpeed. getSpeed. That accepts 2 int arguments, distance and time. So we have the first one, distance, which is an integer. And next one is time, which is also an integer. So inside the function, create a variable called speed, okay, that is equal to the value of distance over time. Cool. And use println and this string template to output the following statement: speed meters per second. Cool. We already did that. Let's run. And now invoke the getSpeed function inside main. Okay, get speed, pair of parentheses, and now I need to pass some values in place of these arguments. The first argument should be 10, and the next argument time should be 3. And I think we will see it later, but I want to show it. So let's run this first, and I will show you a cool feature of Kotlin. You can also use the exact names here, like it supports a different syntax. Distance equals 10 and time equals 3. So whoever reads this line of code will see what are those values you're passing, what is 10 and what is 3, without going and checking the function declaration. They will understand, okay, yeah, distance is 10, time is 3, and it is 3 meters per second. Cool. But yeah, here, let's undo these. Maybe Codecademy will show us this syntax. Let's go to the next exercise and check it out. Yes, named and default arguments. We can go further with arguments by naming them or setting default parameter values. To improve the readability of our code, we can name our arguments when invoking the function. That is what I just showed you. You can use the argument names here when you're invoking the function. And now, since you give named arguments, since you use named arguments, you can swap or change the order of arguments. Normally, you need to pass mass first and then acceleration. However, since we are using named arguments, then we can mess up with the order and like call however we want. Note that by naming our argument, when we invoke a function, we do not need to place the arguments in the same order as they appear in the function header. Yes. Default arguments. Okay, the second important thing about arguments. Provide values to function arguments if none are given when the function is called. So normally, since these arguments have no default values, you have to pass values when you're invoking or calling this function. But if you have a default value for any argument, you can skip giving or skip passing a value inside when you're invoking that function, because now it supports, it has a default value, and if you don't pass any value for any for this argument, it will use this string. Okay, for example, let's say we have a function called greet customer, and this function has the argument name, which is a string, and has the default value customer, and we print hello name with a given name. So if you pass a name, for example, if you say hello greet customer Safa, then it'll print hello Safa. But if you don't give anything inside, then it will print hello customer. Okay, is it cool? Cool. Let's do this. An online shop has a special coupon code to get 50% off a customer's final purchase. Create a function called getPrice. Okay, function getPrice that accepts a double type argument named price. Okay, price is a double, as well as a string argument called coupon code. Coupon code, which is a string, I guess, and has a default value of none. Okay, so this is how you put default values. You put an equal sign here and then put the default value. The type of this default value should be the type of argument, the same. Okay, and leave the body empty for now. Okay, we will leave it empty and run. Sorry, we forgot the empty body. Now we have an empty body, so we pass this one, and now inside the function declare a double type variable called final price var final price, which is a double. Okay, and then create an if-else expression. If the value of coupon code is save 15, set final price to price times 0.75. Okay, and the else statement set final price of price. Final price should be just price because no coupon code. Outside the conditional here, use println and a string template, not println, but println, and a string template to output the following statement: the total price is final price. Okay, $sign. Cool, let's run this. Nothing will appear here, but we also have something wrong. Coupon code, final price times maybe 0.75. Okay, cool. They coded the test that way, so we need to write the exact thing to pass this step. And in the third step, now inside the main function, I need to invoke get price. And when invoking, use named arguments to give price a value of 48.0 and coupon code a value of save 15. Cool, let's run this. Okay, since we have a coupon, we save 15% off. Optional. Cool, I like optional exercises. Invoke get price for a second time. This time only give the program a single argument. Now since we don't use named arguments, compiler will assume, or our program will assume, that we're calling get price with only the price argument is given because it is the first argument here. And since we don't pass a second argument, it'll use the default argument as none. So the final price won't change and it'll print 48.0. Yes, the total price is 48. Cool. Return statements. The functions in the previous exercises produce output via println statements contained within its code body. However, we also have the ability to return a value from a function. Yes, functions can return values to the place where you invoke them. A return statement returns a value from a function and passes it back to where the function was invoked. This value can then be used throughout our program. If we want a function to return a value, we must add the return type to the function header as well as a return statement in the body. Take a look at the following example where we create a function that takes in a list of integers and returns an int value. So this function is called listSum and has a list of integers. This is how you read those types, called mylist, and the return type here is called return type is integer. So whenever you invoke this function, you get back an integer. Whenever you invoke, you get back an integer. Cool. And what this does is it iterates through each value of this list and add this value to the sum variable it defined, and it returns it. So list sum is adds all the value in a list and return that sum back, okay, as an integer. Okay, the return type describes the data type. Yep. Yes, after the parentheses you put a colon to do that. The keyword return, this is another important thing, is a statement, and it's called return statement. And in this case, sum is returned. Okay, this is the value we return afterwards. Any lines of code that exist after the return statement will not be executed. So this is also important. Let's say after the return you have a println, but you put that, this won't get executed, okay? Because when you return, it exits the function altogether. So you cannot put any code after a return statement. You can, but it won't be printed, or it won't be executed. Cool. Previously, we invoked functions by calling them on their own line of code. However, we can also invoke a function and assign it to a variable for later use. For example, we can set total to the return value of list sum after sending it a list of int values. What does it mean? So let's say we have this list sum, okay? And we create a mutable list of 44, 29, 104, and 79. And the list of those integers are now stored in bills to pay variable, okay? So now when we pass this list into the list sum function here, okay, by typing the name, adding a pair of parentheses, and passing this inside, now this will get executed. And it's not only being executed here, but also the value returned by it. So this will return sum, okay, which is the sum of all these numbers. And we store this value, the returned value, into total, so that we can use total later on in our code. This will output the following. Your bill total is $256. This can come confusing to you, but believe me, this is like a so common thing that you'll use so commonly when writing code, and you will get used to it, and this will come natural in time. So for me, this is really natural. You call a function, you pass some arguments, and it optionally returns a value. And if it returns a value, you can store that value in a variable. And this is really natural to me, and it'll be natural to you as well. Now let's do the exercise. Following a recipe for a vanilla cake, you're asked to add 0.75 ounces of vanilla extract. However, you only have a teaspoon to measure the ingredients. Okay, teaspoon, yep. Create a function called ounces to tablespoons, or oz to tsp, that takes a double type argument named oz and returns a double type value. Okay, let's go one by one, step by step. Create a function called oz to tsp. Okay, this is our function, but it should take a double type argument named oz. So oz and double. This means we have an argument needed passed here, and it's a double variable. And inside the function, create a variable called tsp, whose value is oz multiplied by 6. Use a return statement to return the value of tsp. Cool. Yeah. So whenever this is called with some argument, it'll multiply it by 6 and return it back. Let's run and see if it pass. Nope, we didn't pass. And why is that? We have a syntax error, type mismatch, inferred type is double, but unit was expected. Yeah, we forgot to put a return type. Since this need to return a double type value, we need to put double here, okay? So running this, we will get rid of this syntax error and get a check mark. And inside main, create a variable called tsp needed, I think here, tsp needed, and set its value to oz to tsp, because we need to capture that returned value from this function. Okay, we use this for that reason. And pass how much? Yeah, the argument is 0.75. Now we will find out how much tablespoons, how many tablespoons is this measurement. Okay. Sorry, we forgot to use println. Yep. And we need to pass this as a string template. You will need TSP, needed TSP of vanilla extract for this recipe. Okay, let's run this. Cool. Now it calculated 0.75 times 6 and return it back, and we captured the returned value of from this inside this variable, and then later on we use this variable to print something valuable to our user. Cool. Okay, we have 3 more exercises. Let's not split this video then. Let's continue. Single expression functions. Let's say some of our programs has these kind of functions. It just returns one expression, okay? These are called single expression function. And there is some easier syntax to denote this. Since all of the function does is just returning some value, we can get this value and put an equal sign and then put this expression here. So this is another responsibility for equal sign. Equal sign means assignment, equal sign means named arguments, and now here equal sign is used in single expression functions. This doesn't mean get this value and assign it to here, but it does a similar thing. It says this function returns, okay, returns this expression in a shorter way. Instead of writing this, you can just write this. And even shorter, since Kotlin compiler is smart enough to understand this is integer times integers and returns an integer back, it can infer the return type of this function. So you can just omit writing the return type. I said that it is optional, so you can pass. You can omit writing it here. So you can make this shorter and transform it into this if it has just one single return expression. Okay. Create a single expression function called pyramid volume. Okay, function pyramid volume, and the function will accept 3 int type arguments: L integer, W integer, and lastly H is integer. Yep. And this and this has a return. This has to return the value of L times W times H over 3. So we need to return this. Normally we should create a block of code and type return and then type this, but since this is a single expression function, we can type this instead. Okay, and this will make it shorter. Okay, let's run this and see if we did correct. Yep. And now inside the main, create a variable called volume. and set it to the value pyramid volume, and pass length, which is 5, width, which is 8, and height into this function. And lastly, print this in a string template so that we can calculate the volume of a pyramid. Next, function literals. To simplify how we define functions, we can use function literals. A function literal is an unnamed function that can be treated as a value. We can call them, assign them as variables, pass them as arguments, and return them from a function as we could with any other value. This topic is an advanced topic, I guess, but just let's go over it. You don't need to understand it well, okay? You can learn it after you do some exercise in Kotlin, because this is a bit advanced. Okay, so now the syntax changes. Instead of writing fun, starting with fun, and then putting the name, we instead create a variable and then type an unnamed function. So you store this function in a variable. So this variable has a type function, okay? It's not a string, it's not an integer, it's a function. And the function it's stored has no name. Okay. We store this inside a variable. And this now has a function type of double to double. So it means it needs to get 2 doubles and it needs to return 1 double. Okay? And now we can use this as a function name, quotient is a function name. Okay, we can use this because it's a function type. And lastly, we can represent this unnamed function as a lambda expression. It is very similar to an anonymous unnamed function. However, its concise syntax makes lambda expressions a more popular option amongst programmers. Yes, so we usually use lambdas, and I can swear I never used this in Kotlin. I use it in different languages like JavaScript, this kind of syntax, but never in Kotlin. I always have used lambdas. Lambdas is a different notation. It can be a bit hard to understand, okay? But as I said, this is a bit advanced, so I'm just like going through very fast without explaining things in detail. You don't need to understand it very well. You just have an idea of what lambdas are. Lambdas are like unnamed functions, has a different syntax, very similar. But now, this is a lambda. You start with a pair of, again, curly brackets, but then you place the arguments here, like argument name, colon, type, comma, argument name, colon, type. And then you draw an arrow, and using this arrow, you denote that this is what should be returned, okay? So now this will again print 2 because it'll get the num1 and get the num2 and then return it back. So you can call this as a function, okay? Cool. Let's quickly do this exercise. It says create a variable called area and set its value to an anonymous function, not a lambda, anonymous function that accepts 2 integer arguments. First is base and int, and height and int, and this should return an integer. And the return value should be base times height over 2. And now we can use a println to output the value of area 15 comma 19, and then run this. Now area can be used as a function, and it's not outside of main, it's inside of main, and we pass this 15 as the first argument and 19 as the second. Step 2. Now create a variable called perimeter and set its value to a lambda expression. Now perimeter, and now it should be a lambda. Okay, so for lambda you don't type fun, you don't put this parentheses here, but you start by typing a pair of curly brackets and two integer values, side 1 int and side 2 int, and return with an arrow. Now return side 1 plus side 2. And now we can use a println statement to call perimeter as a function call. Perimeter, we can invoke this by giving again some arguments, by passing some arguments inside. So now 15 will go to side 1 and 24 will go to here, and then it'll return side 1 plus side 2. So this will be calculated into 39 and then printed here 39. Let's run this and see if we are correct. Yes, we get 39, but we could not pass because, we forgot to add times 2. So I need to also type times 2. Let me adjust this a little bit. Okay, so we will now see a different value to 39 times 2, which is 78. And we passed this exercise. Now review. I know we've learned a lot of things, and if you ask me, it was too much for just a video or just one unit, because lambdas can be a different topic. Unnamed functions or anonymous functions can be a subchapter. But yeah, the first parts of this video, this episode, will be really important, like how to call functions, how to type named arguments and such. You can watch it later on again to make a review. But even though you can do that, I will do a review no matter what. Okay, a function is a reusable block of code that can be invoked throughout the program. In order to execute a function, it must be called somewhere in the program. An argument is a piece of data fed to the function. Arguments have the option to be named and given default values. A return statement returns a piece of data from the function to where the function was called. Functions with only single expression can be written with a single line of code using shorthand syntax, and I like this feature really much. And a function literal is an unnamed function that can be passed as an expression, and it never talks about lambdas in review. This is a bit weird. I think they also think that lambdas is a bit too advanced for this, but no matter what, they wanted to include it into this curriculum. Okay, if you're confused, don't worry. After you see lots of examples, you will understand the whole concept much better. Okay, until then, see you in the next video.